Welcome to the Data Exchange, the podcast where we explore stories. And this includes the challenges, use cases, new tools, and everything that pertains to the future of artificial intelligence and data management. I'm your host, Ben Lorica. And today we're exploring a crucial barrier that's holding back the full potential of generative AI. So, have you ever wondered why, despite the rapid advancements in generative AI and foundation models, that some of the most promising applications still struggle to reach their true capabilities? The answer, as we'll explore today, lies in data. The deeper I explore generative AI, the more I confront the complexities of integrating custom data to improve the performance of the applications I'm trying to build. So, for example, whether I'm trying fine tuning or building retrieval augmented generation systems or even GraphRag, the success of all of these applications and approaches hinges on our ability to harness the power of unstructured data locked away in different formats. And despite the growing demand for tools to facilitate these new data requirements, investment in data tools hasn't kept pace with other areas. So, I think we hear a lot about all of these frameworks for building applications and startups behind them, but we're just beginning to see new startups for unstructured data. So if you remember, there was an influx of data engineering tools and startups that emerged a few years ago, but they were focused on building and orchestrating data pipelines for structured data destined for data warehouses and lakehouses. So the question is, where are the equivalents for unstructured data in this era of generative AI and large language models? So building generative AI and LLM prototypes might seem straightforward, but if you want to do something robust and replicable, this demands a sophisticated approach to data management and data engineering. The primary hurdle: you have to modify established data practices to accommodate these new, novel, and diverse data types employed by generative AI. Add to that the uncertain long-term costs and the evolving regulations surrounding generative AI, and you've got a recipe for complexity. But there's a silver lining. It seems to me that the landscape is shifting positively. There are more tools emerging specifically designed to handle the unstructured data that fuels custom generative AI and LLM applications. So where are we at today? So if you ask me, do I think can generative AI still reach its full potential? Absolutely. But I think it will require rethinking our data engineering and data management strategies. So this includes things like data gathering and ingestion, data preparation, data refinement, and data utilization. So each of those steps will be crucial if we want to be successful in generative AI. Part 2: Paradigm Shifts. So, in this rapidly evolving world of generative AI and foundation models, I think one of the most critical yet underestimated challenges is data processing and data preparation. So models are becoming more sophisticated. We're getting new releases every few weeks, it seems like. But the data pipelines feeding them haven't kept pace, especially when it comes to using heterogeneous computational resources like CPUs and GPUs. So traditional data processing systems that we've come to use are struggling. The reason is they were built for SQL-centric tasks for managing structured data with ease. But generative AI demands something different. It's what some people are calling AI-centric data processing that can handle an unprecedented variety of unstructured data. So think in terms of things like recordings or sales calls, PDF files, or videos. These are data types that go far beyond what our conventional data engineering tools were designed to handle. Even the straightforward document processing pipelines are now more complex. So, for example, if you have a text application, right? So, the data processing pipeline may involve steps like PII removal or OCR extraction or cross language translation, and then end up with vector embedding generation. These AI centric tasks, AI centric processing steps leverage machine learning technologies. So you need to have advanced infrastructure to be able to handle these kind of complicated data processing tasks. So the other change is multimodality, right? So now we're thinking not just unstructured text, but images, audio, and video. These require GPU intensive computing power. So, for example, training a model like Stable Diffusion may involve a CPU intensive pre processing tasks like video decoding, cropping, encoding, and that must seamlessly integrate with a GPU intensive process. So, mismatches like this create bottlenecks, leading to expensive GPU sitting idle while waiting for data. So, it's like trying to run a marathon but with a sprinter's training regimen. And this inefficiency isn't just in training, right? So it impacts batch inference scenarios as well, where suboptimal resource allocation will reduce throughput. So it's a long-winded way of saying that optimizing this balance between CPU and GPU utilization, as well as being able to accommodate multimodal data, becomes crucial for teams aiming to build high-performing generative AI applications. So why do many of these current data tools fall short when it comes to generative AI? Let's take the traditional batch and stream processing systems first. So they struggle to manage heterogeneous machine learning pipelines because those require diverse resources like CPUs and GPUs, like I mentioned earlier. Batch processing frameworks like Hadoop and Spark, for example, execute jobs in sequential stages, which can lead to increased memory usage and underutilization of GPUs. On the other hand, stream processing systems can do pipeline execution across various resources, but they're typically optimized for specific data types, not the diverse heterogeneous workloads required by generative AI pipelines. So the rigidity makes them ill-suited for ML pipelines where requirements can fluctuate significantly between operators and over time. Even machine learning data loading systems, for example, there's PyTorch's data loader and TensorFlow's TF data. They're designed for single node environments and face challenges when you have to scale them to distributed multi-node clusters. Their parallelization approaches often rely on basic libraries like Python multiprocessing, and that can create bottlenecks and inefficiencies. So one project worth examining more closely is Ray Data, which is a compelling modern solution for teams. So it's built on the Ray open source project, the Ray platform, which you can find at ray.io. So Ray Data blends stream processing with batch processing, and it can enable dynamic resource allocation and pipelined execution across heterogeneous resources like CPUs and GPUs. So this adaptive scheduling mechanism intelligently balances CPU-intensive pre-processing tasks with GPU-heavy training and inference. So this prevents bottlenecks and maximizes resource utilization. So it's basically like having a smart traffic controller for your data pipeline. And actually, at the last Ray Summit, it was interesting to see some real world evidence of the effectiveness of Ray data. So companies like ByteDance and Pinterest have reported improvements of 3 to 8 times over traditional systems. So they can efficiently handle petabyte scale data sets across audio and video. And for example, ByteDance successfully deployed Ray data for processing petabyte scale data sets across audio and video pipelines. And they were focused on things like feature extraction and video pre-processing for AI model training. On the other hand, Pinterest adopted Ray data to overcome bottlenecks in their data loading and pre-processing pipeline, which they were using to train large-scale recommender models. So by distributing data loading and pre-processing across multiple CPU nodes and independently from GPU nodes, Pinterest achieved significant reductions in completion time and improved GPU utilization. Now, if you work primarily in large language models, so text applications, there's another tool that I wanted to highlight that works for LLM-specific workflows. This is IBM's open source project, Data Prep Kit. It addresses a critical gap in LLM development workflows because it provides a unified and scalable solution for data preparation. So coincidentally, actually, Data Prep Kit uses Ray as well. So it has a modular architecture, so it enables team to handle diverse data preparation tasks efficiently, and it's easy to use from single machines to large clusters. Part 3. Building better agents through real-time data access. So at this point in the evolution of generative AI, many of the examples that we are building and that I'm seeing are focused on unstructured data, right? So and actually, one can regard RAG as kind of like the hello world example, right? So connect to a repository of unstructured text and then add information retrieval capabilities, and then suddenly you have better context that you can provide to your LLM application. But there's a crucial piece that's overlooked when we're building these applications, which is real-time operational data, which tends to be structured. Now, this might seem like a step back from the cutting-edge world of multimodal AI, but actually I think this is one of those things that will make AI agents and AI applications much more capable. So right now, the way I see it, AI applications and agents are harmstrung a little bit because basically they cannot connect to business-critical data, which tend to be stored in systems like, let's say for payments, you have PayPal and Stripe. For logistics, you may have UPS and FedEx. You might have CRM systems. You may have transactional databases. Of course, there's ways that you can connect to these systems, right? So, for example, you can use traditional ETL pipelines, but they are tend to be batch processes. So any data that you'll receive and pass through your agents is stale. So it might not make your agents be able to answer up-to-date information, right? So integrating with real-time data sources is actually going to be critical moving forward in 2025. So you can also imagine, okay, so maybe I'll just use RAG, but as you probably are aware of, RAG is great for documents, but maybe weaker for relations. Some people are using function calling, and that works, but function calling is purpose built. You have to build it for each data source that you want to connect to, so it tends to be hard to scale. So addressing this chasm, this data chasm, is imperative. So imagine you have a chatbot that can instantly access live order statuses and customer histories, right? So your AI agent support application suddenly becomes more interesting, right? Or real-time analytics tools that can integrate live data across sales and supply chains and really enhance your business agility. So generally, autonomous AI agents could make informed decisions based on up-to-minute operational context if you can just connect them to these data sources. One promising solution is Snow Leopard, a platform designed to bridge the AI operational data divide without overhauling your existing infrastructure. So the way Snow Leopard works is it introduces an intelligent layer that communicates directly with existing systems using their native protocols, so APIs or SQL calls, whatever the native protocol might be. So then Snow Leopard enables your AI applications to access up-to-date data without the latency and complexity of traditional ETL. And by employing intelligent query routing and native integrations, Snow Leopard eliminates the need for custom connectors for each data source. So this simplifies your integration process and fundamentally changes how you build AI applications and how those applications interact with live data, and thus making their insights much more real-time and much more relevant. So some early users of Snow Leopard are from fintechs and some software as a service companies. So they are able to maintain data fidelity and eliminate transformation steps. And this allows them to really address a major pain point in their AI development. Snow Leopard promises to support multiple use cases across various data sources without extensive customization. So this is really a meaningful shift towards more efficient and responsive AI applications, more interesting agents really moving forward. So looking ahead, tools like Snow Leopard, and there's another tool that I really love to use these days called BAML, B-A-M-L, which is an open source domain-specific language designed for structured text generation with large language models. So think of BAML as a very small domain-specific language. It'll take you about 1 to 2 hours to learn it. And this will allow you to really work with prompts and manage your prompts, test your prompts in a much more principled way. So you can really inject software engineering rigor in how you build these LLM applications. Another thing worth paying attention to is Anthropic's new Model Context Protocol, an open standard for connecting AI assistants to external data sources and systems. So it's this MCP, Model Context Protocol, is community driven. So there's a lot of people beginning to work on it, and this is another open source project that you should definitely be aware of. So Snow Leopard, BAML, Model Context Protocol, as all of these tools mature, we can expect a dramatic evolution this year in agent capabilities, because now agents will be much more aware of the context they're operating in, because now they have access to real-time operational data. And this will allow AI teams to deliver on the promise of autonomous decision making. Part 4, the bigger picture, data for generative AI. We are in an AI arms race where data remains the ultimate fuel. The equation is simple for those who are building frontier models. Bigger models plus more data plus more compute is translating to better performance. But here's the kicker. The teams behind the leading foundation models are confronting a significant data challenge. And many experts predict a potential high-quality data drought as early as 2025. After all these teams have already scraped the internet. Now, the reason I'm interested in what all the teams who are building foundation models are doing is because some of the challenges and therefore the resulting tools that they are building to overcome those challenges are tools which will benefit all of us who are building AI applications. So the impending scarcity, for example, underscores the importance of innovative data strategies to maintain momentum in AI progress. So one of the lessons that these teams have learned is quality over quantity. High quality, domain specific data is a key competitive advantage. And that is especially true for those of us who are in regulated industries like finance and healthcare. So many of these teams are now beginning to emphasize the importance of data quality. So all these teams, beginning with Mistral AI when they first announced their first model, now are highlighting how they have meticulously curated data sets and have negotiated licensing agreements to differentiate their model training. A small, high-quality data set can yield really superior results compared to a massive, inconsistent corpus of web-scraped information. Another critical distinction which I have made earlier is between the data used for training models and the data required for reasoning and decision making in applications. So you heard me talk earlier about real-time operational data and how access to that can really translate into really interesting AI applications and AI agents. So these AI systems devour historical data during training, but they really thrive on fresh real-time information when tackling real-world challenges. So data augmentation is also important here. So synthetic data can supplement existing data sets, and it can help us address gaps where real data might be limited. But the key here is it's essential to understand that synthetic data is a supplement, not a replacement. Extensive use of AI-generated data has been found to lead to model collapse. And this means diminishing output quality and impacting the generalizability of AI models. So effective data selection and curation are crucial for your AI applications. So make sure you invest in techniques like improving your data quality, making sure your applications have access to real-time data, and also make sure that you understand that even though you are working with unstructured data, there might be structure in that unstructured data that you can leverage. So the classic example right now is GraphRag, right? So where you can take a bunch of text or maybe even your relational database, and from your underlying text construct a knowledge graph, which can then help your RAG in the retrieval process, and therefore give you much more targeted and much more relevant information. Besides the fact that the knowledge graph will help with explainability as well. So the increasing value of high quality data means you might also want to look into data licensing and data partnerships. So strategic collaborations can fuel the development of highly specialized domain-specific models, which might set your model apart from your competitors. So for example, OpenAI has licensed data from media companies like Reddit, the Associated Press, and Financial Times. So as we look to the future, the magic happens when data quality and data processing and scalable data processing tool meet strategic augmentation. So the real winners in the AI race will be those of us who excel not just in post-training models, fine-tuning and RAG and all of this, but also those of us who excel in the art and science of data curation, strategic data sourcing, and extracting structure from data will ultimately be at a competitive advantage compared to other teams. So combining your AI expertise, domain knowledge, and your skills with data processing and data curation will allow you to basically leapfrog your competitors. So in conclusion, data is the lifeblood of generative AI. By prioritizing data quality, embracing strategic augmentation, and building robust, scalable data management and data processing solutions, you can unlock the full potential of generative AI and foundation models. So this AI journey isn't just about models and advancements in models. It's about mastering the intricate dance of data that fuels the next generation AI applications and services. And I'm looking forward to what you folks can build, especially once you figure out how to connect your AI applications with real-time data sources. So thanks for joining us on this episode of the Data Exchange Podcast. Make sure to check the episode notes where I have links to relevant articles and resources. And please join the thousands of people who subscribe to our newsletter, which you can find at gradientflow.substack.com. Thanks for joining us. If you like the show, please subscribe and rate us through Apple Podcasts or Overcast or TuneIn.com or Spotify and never miss an episode. The Data Exchange Podcast is a property of Gradient Flow. This is Ben Lorica, and I'll be back next week, and we will do this all over again.